of, like you said, 1.5% space dust plus the regolith, no more than 15 centimeters high. I'm sure going to the moon was a very traumatic thing, and the astronauts were probably worried about a lot of stuff. But do you seriously think that we would have sent someone to the moon if they had been able, thought to have had to cope with 500 or 1,000 feet of dust? It just doesn't make any sense.
I will certainly send you those quotes, and you can deal with those people who say, what you gave here is an example that you said might give 10 centimeters of dust, which is about 3 inches, was only, if you call her slide back up there, could you do that, the one you just had? I don't get to discuss this one? She only gave one dust particle size. There's lots of sizes coming into the moon. Anyway, well, let's see. All my questions have to come from my notebook. Let's see. Could you please explain, question 13, when, where, why, and how did single-celled plants become multi-celled? And where are the 2-celled or 3-celled or 4-celled organisms in the world? Why do we have nothing that is 2-celled? We go from single-celled to multi-celled. How did they make this jump, please?
Go ahead. That's pretty easy. Volvox, gonium. Gonium has 4 or more cells. There's no specialization. Volvox has hundreds of cells embedded in jelly. Some are modified for reproduction. If you're looking for intermediate forms, these are 2 perfect intermediate forms that happen to still be around. When did they go to multicellular? Well, there's evidence in the fossil record of multicellular algae about 800 million years. I don't know what the big deal is about having 2 of them. I've got 4 of them right here. In 1 billion to 700 million-year-old rocks in China, Norway, India, and Canada, we find these multicellular algae. The first land plants, 450 million years ago. The first vascular plants, 408 million years ago. There is a progression with plants as well as animals.
What you gave was an example of a colony or several cells working together. We have the same thing here in a city with several people working together, some doing different jobs. That is not an answer to the question of how did it evolve. Finding something in a rock layer, we still have these creatures that you showed on the screen alive today. They're still here. So finding them in a fossil record, which I think I showed you pretty clearly, the fossil record is based on circular reasoning, is not evidence at all. And that finding them in a colony, several cells working together for a common good, is still not the same thing as a tissue or an organism. So I think you did not answer that question at all as far as how single-celled creatures became multicellular. Because there is no answer to this. As any biologist who understands their stuff will tell you, we don't know. We think it happened because we're here, but that's not science. That is religion, which is my whole point. It's all based on something you have to believe. You think it happened, you're welcome to think that. But nobody should be allowed to use taxpayers' dollars to spread that kind of propaganda in our school system. That's not science. Am I supposed to ask a question?
Your information concerning measurements of stellar distances is outdated, to say the least. What is your basis for restricting parallax measurements to only, I believe you said, 20 to 100 light years, and possibly ignoring all the other types of distance measurements completely?
The way star distances are measured, I cover pretty thoroughly on my question-answer tape number 7. I don't have time to give you all the details on that now. But to measure star distance, you have to have 2 observation points if you want to measure it with parallax. And it appears to me like by your question you are admitting that they really only can measure through parallax distance, as trigonometry, a short distance. Maybe 20 light years. Some textbooks say 100. That's a stretch. And I've got the actual measurements in my seminar notebook, or I can show you pictures of that if we have time. But if you have 2 observation points on opposite sides of the sun, opposite sides of Earth's orbit around the sun, is 16 light minutes across. Now, how you could tell in June where you used to be in January across the orbit of the sun, how you can tell that precisely, I find to be a big question. I don't think you can tell exactly where you were 6 months ago, opposite side of the sun. But even assuming you can, you're 16 light minutes apart. 1 light year is 525,926 minutes, I believe. A little over 500,000 minutes in 1 year. So if you're going to take a triangle that is 16 inches from point A to point B, point C that you're going to try to measure to is 8¼ miles away. You get me 2 surveyors to set their transits up 16 inches away from each other, focus on a dot 8¼ miles away, and tell me the precise angle. That's for 1 light year, assuming you can know where you were 6 months ago going around the sun. I don't think any of that's possible. All the folks who understand parallax trigonometry will say it's only good for even 20 light years, I think, is a stretch. The fact is we don't know the distances to the stars. Now, if you want to use luminosity or red shift or Cepheid variables as your evidence that they're billions of light years away, we could certainly talk about that, but not in the time constraints we have here. There's lots of folks who will simply say, we don't know the distances to the stars. We think they're pretty far. Another problem is if you're going to use red shift, for instance, as an example of telling the distance to a star, because we see the light, the red in the spectrum shifted away from the other colors, does not prove it's traveled great distances, or that the star is great distance away. The whole idea behind a black hole is that light can be attracted by gravitational forces. So therefore the light cannot escape from the black hole. And if the starlight is traveling through space, going past all sorts of different gravitational fields, we don't know what's going to happen to it. We know that light traveling through glass can be bent. You can get the rainbow on a piece of glass right here in the desk if we had a light in a prism. And so light is bent. Different colors travel different speeds. The red bends farther because it's a longer wavelength. And so the red shift, the Cepheid variables,